So coming on to our formal definition of a grammar, we're going to define this as a tuple of four things. And remembering that a tuple is a sequence or a list of things that may or may not have the same type, or they may have different types. So within this tuple we've got four things. First thing is the set of terminal symbols. So that's the set of things that can appear in the actual character string we're trying to recognize. Vn is then the set of non-terminal symbols. That's all of the sort of structure, the virtual nodes, as it were, that don't appear in the text itself, but will be used to classify and cluster the things that are in the text. Given those two things, the terminals and non-terminals, we then need a set of production rules which are mapping a left-hand side definition to a right-hand side one possible production of that definition. We also need this final thing, which is the start symbol, and this is trying to say what is the top level piece of structure, what does an entire well-formed sentence in this language look like. So in the case of C, S could be something like program or translation unit possibly. In the case of a CSV file, it might be a list of lines or something like that. It's the uppermost thing, the thing that contains everything else. Within this tuple, we've got some derived properties. So one thing we can talk about is the total universe of symbols. So that's simply the union of the terminals and the non-terminals. So V is all the possible symbols that can appear, whether they appear in the language or whether they're sort of these virtual clustering things. An important requirement for formal grammar here is that these two things have to be distinct. There should be nothing that's in the terminal set and also in the non-terminal set, and well, vice versa. This set of production rules, we can actually specify it more tightly by saying that each production rule is a pair with a left-hand side and a right-hand side. And if we remember that Greek letters represent sequences of symbols, on the left-hand side it's a sequence of one or more symbols because we have to be defining something, we can't define nothing. And on the right-hand side it's zero or more symbols, and that's because we might define something to be nothing, or essentially to be epsilon. This syntax here, the V plus, so if I said V, that would mean any element from V. If I said V cross V, that would be any pair of elements from V. This is anything from V, anything from V times V, anything from V times V times V. It's all possible tuples of things from that set. This asterisk notation here I'm using to say, well, it could be anything from V plus. It could be a single element, it could be a pair, it could be a triple, but it could also be nothing. It could be emptiness. So trying to define a formal grammar for our running example, first thing I do is define the set of terminals. So I'm using curly brackets to denote set construction. And within that set, I simply have all of these characters. Now I'm using the shorthand that quotation means this is the thing that will appear in the actual text. I can also define my set of non-terminals. Note that I'm not really saying what these things are. So expa and oppa, they are part of the set of non-terminals, but what exactly they are is not actually, well, it doesn't matter what they are, as long as they are distinct from each other and as long as they are distinct from everything in the terminal sets. Given VT and VN, we can then talk about production rules. So a production rule is a pair. It has a left-hand side and it has a right-hand side. The left-hand side is one or more symbols. In this case it's one because we've got a nice simple grammar. And the right-hand side is zero or more symbols. And so in this case it consists of 1, 2, 3, 4, 5. It's a sequence of 5 things. In this case it's only a sequence of one thing. This one is defined recursively. These ones are defined non-recursively. But they're all valid production rules. And the final thing I need is simply to specify, well, what's the start symbol? In this case, it really has to be expa, because if I said that the start symbol was oppa, there would only be two valid sentences in this language, the sentence plus and the sentence times. By saying that the start symbol is expa, we're saying that it must be one of these more structured things. Otherwise, we're defining something too simple. This is designed to look like data. It's designed to look like something that you can specify in something like Python or C or something else. So grammars in this sense can be represented and captured as pieces of data that you can then write programs to actually deal with. We'll exploit that later on. So within this grammar, we've got terminals. They are appearing on the right-hand side of productions in this case, because on the right-hand side we're consuming characters and making things simple. Non-terminals can appear on the left-hand side or the right-hand side because they are defined in terms of themselves. So as I said, I structured that to make it look a bit like code, and it's quite easy to sort of work out how you could actually capture a grammar, or any grammar, as a piece of data in a program. So in order to simplify things, I said that we have to we have to know what symbols are, but we don't really have to worry about what they are. In an actual data structure, we must know what these things are. So one convention can be a terminal symbol is a quoted string, and a non-terminal symbol is a unquoted string. That ensures that I can actually make these two sets of things distinct. And now I've got this just a class called symbol that can represent either a terminal or a non-terminal. Given symbols, I can define what a production rule is, and a production rule is simply a pair of a left-hand side and a right-hand side. The left-hand side is a sequence of symbols. In this case, it's a sequence of strings. The right-hand side is also a sequence of symbols. The only real difference is that for this one, there must be at least one symbol in this vector. On the right-hand side, there's no such restriction. So now we've defined the type of a symbol, we've defined the type of a product, or a production rule. That then means we can quite easily define a grammar to consist of a set of symbols, actually a set of strings, a set of terminals, actually also a set of strings, and a set of production rules, which is a set of objects that look like this, so pairs of left-hand side and right-hand side. And then we can define the symbol S as just the string that must appear first. So this is actually something that can be turned into actual sort of executable C++ code. So by defining these grammars very formally, we've actually given ourselves a way of describing, representing, and potentially manipulating grammars.